Hello everyone. I hope you guys are doing great. Myself Kittu Patel, and today in this video we are going to verify JK flip-flop. So this video is a part of our verification series, and trust me, you won't find such content anywhere else on YouTube. So we are trying our best to take you inside this field and guide you towards opportunity in top MNCs. So if you are new here, make sure you become a part of our family by watching the full video. And if you have any queries, so feel free to contact me on the given contact number or mail me on the mentioned email ID. Now coming back to today's topic, we are going to verify the JK flip-flop. Also, I have a small verification task for you. So on YouTube, you see that subscribe button. Go ahead, press it, and let's check whether it is working properly or not. So yes, that's your verification task. Go ahead and perform it right now. Now let's start the video. So this is our flowchart. So first we will see the architecture of our entire TV. Then we are going to see the RTL. Then we are going to jump into the test bench. So let me explain you first of all our architecture which we have made. Okay. Which we have done in order to verify our JK flip-flop. So see, first of all we have transaction class. So the intention of using transaction class is to just declare all the UVM field macros or UVM macros field, and also here we have declare our signal to a rand type or not. So see, since we are providing JK as an input, so we want a randomized JK input. So that's why we have considered J and K as a rand type, whereas our Q is an output. So there we haven't considered Q as a rand type. We will see in code also, so don't worry. After that we have considered three sequence. So one sequence is like valid JK. So here we are passing the valid JK input and checking whether it is giving the correct output or not. After that the second sequence is reset. So here we have kept our reset low to see the effect of output or effect on output. After that we have checked the third condition, that is random test. So in random test, so you have random JK inputs and also your reset is random. So we have considered three sequence. Okay. So each sequence will considered as an one test case. Now after this sequence, we have sequencer class. So see, the role of your sequencer class is nothing but it acts as an initiator. So suppose let's say this is your sequencer. Okay. So let's say sequence has generated some transaction and driver has requested some transaction. So the role of your sequencer is to just collect this sequence or transaction from your sequence class and store it in their FIFO. Now driver will continuously monitor that sequencer FIFO, and if some transaction available at sequencer side, so driver will get that transaction. Okay. So that is the role of your sequencer. Now after that we have driver. So the role of your driver is to drive the data which we have received from the sequence to a DUT. Okay. So let's say driver has received the data. Now it pass your data or transaction which we have received from our sequence to your DUT via interface. Okay. So we have interface in between the DUT and driver. So we can pass our sequence to DUT via interface. Now after that we have monitor. So monitor will collect the data which DUT gives, or you can say the monitor will sample the data from your DUT or interface. Okay. So it will sample your data. After monitor we have considered one scoreboard class. So the role of using scoreboard class is to just check that whether the output which we are getting from the monitor are correct or not. Okay. After scoreboard we have agent class. So in agent class we are building our sequencer, driver and monitor. Okay. So in sequencer or in agent class we are building sequencer, driver and monitor. And also like whenever you are going through the architecture, I have already explained the architecture in our previous video. So you can see that in agent our driver and sequencer are connected to each other by a sequence port. Okay. So that connection we should establish in our agent. After the agent we have environment class. In the environment class we are building our agent, and after environment class we have test class. So in test class we are running multiple sequence on their sequencer. Okay. After test class we have the TV top. So this is our overall flow. I have given you the rough idea, then we will see the code so it will be a more clear for you. Okay. So this is overall our implementation should look like. So let's move to a RTL. Okay, so see, this is our design. So in design, you can see this. We have considered one module JK flip-flop, and inside the module, we have considered clock, reset, J and K as an input, and our Q is output. Initially, I have given output as an 0. Okay, so this is our 5 signals which was there in JK flip-flop. Now, if our reset is low, I have considered the asynchronous reset. So if our reset is low, so the output is 0, and if reset is high, checking the condition. So if J and K are 0 0, so the output will latch their previous value. If J and K are 0 1, so output is 0. If it is 1 0, so the output is 1, and if it is 1 1, so the output will be complement as compared to their previous value, okay, or previous output. So this is our, you can say, more overall design. Now we have interface. So in interface, I have just written all the signals J, K, reset and Q, okay, and I have considered our clock as an argument of your interface. Now this is your RTL. I hope RTL is clear. Now let's move to a main part, that is verification. Okay, so this is our verification. See, I have already written this code, so I am going to explain you each line. So please watch the full video because you will get the meaning of each line, why we have used that. Okay, so please watch the full video for that. And yeah, if you are looking for the code, so I am going to attach the EDA link in the description. So here in first line we have used tick include UVM macros.svh. So it allow us to use all the macros which was there in UVM. Okay, so just like here we have used tick UVM object, tick UVM component utils. So these all the macros are accessible when we use this include UVM macros.svh. Now here in second line we have import UVM package. So we have import all the package which was there in UVM. Now see, here in first class we have considered the config class. So here the role of using this config class is to just configure our agent, whether our agent is active agent or passive agent. See, your agent is of two type, active agent or passive agent. So in active agent you can build your driver, monitor and sequencer, whereas in passive agent only monitor has been built. Okay, so that's why I have considered one config class externally. So here config class is of UVM object type, and keep this in mind, whenever you have UVM object, so you can just pass only one argument in your constructor, because since UVM object is already a parent class, so that's why it doesn't require a parent argument. Okay, now here we have used tick UVM object utils, and then we have used UVM active passive enum. So here we are setting that we are going to use UVM active, that is we are going to use active agent. Okay, now after that we have transaction class. So just we focus on that, so just keep focus on this. So in this transaction class, first of all we have extended our transaction class from UVM sequence item. Okay, now after this we have constructor. So since your UVM transaction class is of object type, so that's why we have considered only one argument, and then super.new name which is pointing to this name, and then end function. Now see, we want our reset J and K to be randomized because we need different value of J, K as well as for reset, but Q is our output that we don't want to randomize. Okay, so that's why for this J, K and reset we have used this rand keyword, whereas for Q we are not, and whereas for Q we haven't used any rand keyword. Okay, now here we have used tick UVM object utils begin. So this is called a field macro. So in order to print all this in your console, we are using this field macros. Okay, now see, after this we have sequence class. So in sequence class we have right now considered three sequence, or you can say we have considered three test cases. So our first sequence is valid JK. So here we have kept our reset, you can say 1. So that means we are passing a valid JK, because whenever your reset is 0, so our output is 0. But here we have externally kept our reset 1. Here you can see this. So this is valid JK. Okay, or here your UVM sequence, and here your sequence class is extend from UVM sequence, and since it's an object type, so that's why we have used tick UVM object utils, and I have already covered that in object class constructor you can just pass only one argument. Now task body which we have taken, Now task body we have considered and we have randomized 5 times, or you can say we have repeat our loop 5 times. Now here we are creating our transaction. So you can create transaction like this. Now we have used start item. Now we have used start item and then we have randomized with, we have written one condition that your reset should always be 1. Okay, if your randomization fails, so you are giving or you are passing one transaction randomized failed message. Okay, and you have used tick UVM fatal. So see, the use of your tick UVM fatal is to terminate your simulation, because see, if the transaction has not been created, so there is no need to go further. Okay, if you haven't any transaction, so why should you go further? So that's why we have used tick UVM fatal. So if transaction has not been randomized and if randomization failed, so we are going to terminate our simulation. Then we have used finish item. After that we have used finish item. Okay, now here we have used tr.print. So here print method will print all the values which we have written in the field macros. So see, here in field macros we have written j, k, q and r. So it will print all that in your console. Okay, so that's why we have used this print method. Now this is your first sequence. Now this is our second sequence. So second sequence we have written for the reset check. So here you can see your reset is 0. So reset is 0 means whatever input of your JK is, we don't have to worry about, because here output is always be 0 because we have used the reset equal to 0. Okay, and our reset is working on the negate only. So that's why we are not focused much about the JK. Here we are checking the reset. Okay, so see, since it's an sequence, so we have extended from the UVM sequence, then we have used the constructor. Now this class or this sequence we have randomized the 5 times, and also this sequence we have randomized 5 times, and then we have just created our transaction. Then use start item. So start item to start the item, and then we have randomized that by using the condition that our reset should be 0, and then finish item. Then here we are printing the all the failed macros. Okay, now after that our third sequence is random check, where our reset is also randomizing and JK is also randomizing. Okay, so here we are checking that, like, if reset is asserted, so whether our circuit is working properly or not, and if it is deasserted, so for that case also our circuit is working properly or not. So it is full random test. Okay, you can say that it is full random test. After this sequence we have the sequencer. So see, the role of sequencer is very simple. It just acts as a mediator. So whenever your sequence will generate some sequence, so your sequencer will just drive that sequence to your driver. Okay, and just pass that sequence to your driver. See, the main part here is driver and your monitor. So let's see. Yeah, so here you can see we have driver. Okay, so here you can see we have driver. Now here we have considered the class driver and extend from the UVM driver. Now see, here we have used tick UVM component utils, and keep this in mind whenever you are using component utils. So components have two arguments in your constructor. So see, while making an object we only have used one argument, but here in component we have to use two argument. First argument is your string name and the second argument is your UVM component parent. It will basically point their base class. Okay, so that's why we have used the UVM component parent. Now see, since our driver is connected to the virtual interface, whatever sequence we are accepting from the sequencer, that we are going to pass it to our interface, and then from the interface duty will collect that sequence. Okay, so that's why we have considered the handle of interface. Now in build phase we are getting the interface. Okay, so we have set it through the TV top, or we have set through the TV top. So here in driver and monitor we are going to get this interface. Okay, so here you can see that we have get our interface by using UVM config db. Now here main part is your run phase. So in run phase we have used forever begin. Here we have used forever begin because we want to continuously monitor our sequence. If sequence available, then we can get the sequence from the sequencer. So first of all, here we have used get next item. So get next item will tell the sequencer that our driver are looking for some data. Then if we received some sequence, then it will get executed. Your get next item is a blocking method. So it will continuously monitor until sequence is not available to a sequencer. Okay, now after execution of this line, here we have send to duty. So the sequence which we have received from the sequencer, we are passing to a interface. So here we have considered one task, that is send to duty. So here you can see we have just connect all the signals to our interface. So here from request is a transaction handle. So the transaction handle which we have received, so the transaction which we have received are connecting, we are connecting to a interface. Okay, so the transaction which we have received, we are connecting to a interface. Now here you can see after that we have considered one NAND gauge of delay, so that we can drive it on the next NAND gauge. Okay, so that it will be easy to sample, so that's why I have done like this. Okay, now after that we have used item done. So item done is a non-blocking method. So if you have passed your transaction or connect your transaction to your interface, so you can just invoke item done. And if you also want to send some response that you have like collected your request, so that you can use the item done. So item done is basically used for sending the response. Okay, now after the driver class we have monitor. So here the role of monitor is to just sample the data which we have passed in our interface or duty. Okay, so it will just sample the data from the interface. Now here you can see we have considered one UVM analysis port. So the role of your UVM analysis port is to broadcast the transaction which we are getting or sampling in the monitor. So we are going to broadcast it, okay, in your scoreboard or another reference model or any component. Okay, so that's why we have used the UVM analysis port. Now after that we have used the constructor. I already have explained this, that if we have components, so we have to consider two argument in your constructor. Now here in the next line we have used the transaction handle and then virtual interface handle, because here from here also we are going to collect our data from the interface, so that's why we have used the interface handle. Now similarly like driver, here also we are getting our interface. Okay, now main part is your run phase. So in run phase you can see we are sampling at every pauses of clock and we are calling the method get from duty. So in get from duty we are sampling or monitoring it. So in get from duty we are sampling all the data from our interface and passing it to a transaction and converting it into a transaction. Okay, and converting it into a transaction. So you can say that here we are collecting data from our interface or pin level activity to transaction level activity we are converting. Okay, so here we have received the pin level activity and convert it into a transaction level activity. After collecting all this data and signals, we are passing it to our scoreboard or another component. Okay, see here we have used send. So send is your name of your analysis port and write is a method which was available with analysis port if you want to send something, and tr is your transaction handle. Okay, so that's why we have used like this. Now after that we have agent class. So right now we are using the active agent. So in active agent you have to build all the three component, that is your driver, sequencer and monitor. So here you can see we have taken the handle of all these three component, and also we have taken a handle of your config jk class. So our config jk class we have used to configure that whether our agent is active or passive. So that's why we have used our config jk class. Okay, now here we have built our monitor first, because see if your config is active or passive that doesn't matter, your monitor is always built. But here we are checking if your config class is active, so only in that case your driver and sequencer will build. So here you can see that we have get from our config db and we have checked that if our config class is UVM active, so only for that case we are creating our driver and sequencer. Now in connect phase, since we are in agent, so we want to connect our driver and sequencer. I have explained that in architecture. Okay, so we want to connect our driver and sequencer inside our agent. So here you can see that we have connected our driver and sequencer inside our agent, and also we have sequence item port that is inbuilt. Okay, so you don't have to declare it explicitly. See, we have declare one analysis port explicitly in our monitor, but this sequence item port is available with your driver as well as for your sequencer. Okay, so we don't have to declare it explicitly. Now see, after this agent class we have scoreboard, or yeah, you can say that scoreboard is basically used to check whether the required see, scoreboard is basically used to check or verify whether the data which we have received from the monitor is meeting with the expected result or not. So it will just use to check whether we are getting the correct data or not. Okay, so we have written a logic inside our scoreboard. Since we have used the UVM analysis port in your monitor, so here we are receiving that by using UVM analysis implement. Now here we have considered one reference output. Now see, here we have written one logic. So if your reset is low, so your output should always be low. Okay, because because we know that our if reset is low, or if reset is low, so our output is low. But if reset is high, so we are going to check this condition. So if reset is high, if your input is 0 0, so output is like your output will be latch. Okay, and if your input is 0 1, so the output is 0 1 0. For your output is 1, and for 1 1 your output will be toggle. Okay, now here we are comparing our actual output and the reference output. See, from here we have generate one expected output, and here we are comparing the actual output or comparing with an actual output. If it is correct or if it is equal, so it will get pass. Okay, so that's why we have used the scoreboard. After scoreboard we have environment class. So the role of your environment class is to just build your scoreboard agent as well as your config class. Okay, so here we have built the three things, that is your scoreboard component, agent component, and config class object. Okay, so here you can see that we have built all these three. Now here in connect phase we are connecting our agent, or you can say we are here in connect phase we are connecting our monitor to scoreboard, because in monitor we are passing some transaction to a scoreboard, so we have to connect that. So that's why here we have connect. Okay, so see, directly you cannot use the monitor instance because we are here in environment. So in order to reach to a monitor, so we have to first point to a agent. So in agent we have monitor, so we have first point that agent, then agent dot monitor, and in monitor we have send port. Okay, so after that we have used the connect, and we can directly use the scoreboard because it was declared here only. So that's why. Okay, now after environment class we have test class. So see, here in test class we are going to check the all the three sequence. So first of all we have built this three sequence and also our environment, and after that we have run all these three sequence. And you can keep this in mind, it's a blocking method. Your start is a blocking method. So while executing this first sequence, your second sequence will not get executed. So first of all your sequence 1 will get executed, and then sequence 2 will get executed, and then sequence 3 will get executed. Okay, after that we have used drop objection so that our simulation get terminated. Now in module TB we have considered one clock, and then we have connected our clock to an interface, and then we have generated clock, you can say. Then we have connected all the signals to our DUT, and then we have used run test. So run test is basically used to run our test. Then we have set our interface from here that we are getting in our monitor as well as in driver. Now here I have used the dump file in order to see the waveform. Now let's run the code and see the expected waveform. Now here we are going to see at each poses. So see, at first poses we have our J and K as 1, and our output is 1, because see, initially our output is 0, so output will be toggle at whenever your input is 1 1. Now here we have 0 0, so when you have 0 0, so your output will be latch. So here you have 0 0, so your previous output is 1, so that now your current output will be 1. Now for 1 1 again it is toggling, so it will goes to 0, and after that we have 1 0, so for 1 0 our output is 1. And then here you can see, for whenever your reset is low, so the output is low for the entire cycle. So see here 1 0, for 1 0 your output is low, for 0 0 your output is low, for 0 1 your output is low. So we have checked that reset also. Then we have considered the random case. So this is how we have verified our JK flip-flop. Now our next target is to verify RAM or FIFO. So if you have found this video useful, then do like this video and also share with your colleagues so that they will get benefited too. Okay, so thank you.